Today we're going to talk about the determinant of a matrix. Suppose A is an n by n matrix. That is, A is a square matrix. The determinant of the matrix A is a number that we associate to this matrix. If the matrix A is a 1 by 1 matrix, where A is equal to any number, any real number here, then the determinant of A is equal to that number. If A is a 2 by 2 matrix, such as this one, where A, B, C, D represent real numbers, then the determinant is A times D minus B times C. So think of making an X here. A times D minus B times C. Now for larger matrices, the determinant is a little more complicated, so we need to introduce some terminology. If A is an n by n matrix, what we're going to do is we're going to pick the entry Aij and delete row I and column j to get a matrix which we're going to call capital Mij, which is known as the minor matrix, and its size is n minus 1 times n minus 1. Let me show you what I mean. Let's choose the entry A13. A13 is this number here, 3. It's in row 1, column 3. We're going to delete row 1 and column 3, and we're going to be left with the submatrix. So M13 is the matrix 4, 5, 7, 8. Let's try another one. Let's say we have A22. That entry is a 5. We're going to delete row 2, column 2, and we're left with these 4 numbers, and M, capital M22, is going to be the matrix with those 4 numbers in the same order, exactly how you see them. So this is the minor matrix corresponding to this entry A22. The determinant of this minor matrix is called the minor of A. Okay, I think we're ready to introduce the determinant for any n by n matrix. So what you want to do to find the determinant is you want to take any row or any column of A. You have to choose whether you want to go down a row or a column. I'm going to give you 2 different ways to find the determinant. The first way is you're going to take the sum from I is equal to 1 to n of Aij negative 1 to the I plus j. J here is fixed. And then multiply this by the determinant of Mij. And we'll go through all of this in a minute. And this definition is if you go down a column of A. An alternative is if you go down a row. So you're going to let J go from 1 to n, and you're going to fix I. And I'm just going to repeat this definition. and this is your row option. Now we're going to actually go through this to make sure you understand the differences between these two definitions and so that you know how to find the determinant of a matrix. Here I have a 3 by 3 matrix, A, and I want to find its determinant. So what you're going to do is you're going to pick any row or any column, and you need to choose an entry in that row and column. We're going to start with the first entry in the row or the first entry in the column, depending on which way you want to go. For example, let's start with this one. This is A11, and I'm going to go along this row. Okay? So following this row definition of the determinant, I'm going to start with A11, then -1 to the 1 plus 1, determinant of M11, and then we're going to go A12, then 1 plus 2, determinant of M12, and so on. In here is 3. So let me write this out. The determinant of A is 1. This corresponds to A11 times -1 to the 1 plus 1, determinant of M11, plus this is going to be the next entry. So 2, this is A12, times -1 to the 1 plus 2, determinant of M12, plus (3), which corresponds to A13, -1 to the 1 plus 3, determinant of M13. We need to figure out what these determinants are and plug them back into this equation here. Let's start with M11. So M11, well, remember, here's A11. We delete the row and the column, and this matrix will be M11. So then the determinant of this, remember you make an X, so it's 1 times 1 minus 3 times 3, which is 1 minus 9, which is -8. So what I'm going to do is I'm going to erase this and I'm going to put -8. Now let's figure out what M12 is. So M12 corresponds to A12. We cross out this row and we cross out this column, and we get 2, 3, -1, 1. So the determinant of M12 is 2 times 1 minus 3 times a -1, or 2 plus 3, which is 5. Let's erase this and put 5. And now we have one more to do, M13. Okay, M13 corresponds to knocking out this row and this column. We're left with 2, 1, -1, 3. And the determinant of M13 is 6 minus a -1, which is 7. So let's erase this and put a 7 here. Okay. Now we just need to clean this up and add these three numbers together. So we'll have 1 times a negative 1 raised to the second power is 1, so we're going to be left with negative 8. We have a minus 10, because 2 and 1 make 3, so this becomes a negative 1. And then this becomes a positive 1, so we have 21. So we have negative 18 plus 21, we get 3. So the determinant of A is going to be 3. Okay, write that down. Now I'm going to show you the other definition using a column. And we should get the same answer. Okay, so you choose the column you like, column 1, column 2, or column 3. I think I'm going to go down column 2. Okay, let's look at the definition. For the column definition, you start with the very first entry in the column at the top of the column. You're going to start with I is equal to 1 and go all the way to 3 because this is a 3 by 3 matrix. And this I is going to change, but the J doesn't, so you're staying in the same column. Okay? So we're going to start with this entry. The determinant of A is 2, which corresponds to A1, 2, times negative 1 to the 1 plus 2, determinant of M1, 2, plus the second item is this 1 here. So 1, which corresponds to A2, 2, times negative 1 to the 2 plus 2, determinant of M2, 2, and then 1 more, this 3. So we have 3, which corresponds to A3, 2, negative 1, 3 plus 2, determinant of M3, 2. I'm going to do the same thing I did last time. I'm going to find the determinant of each one of these minor matrices. Let's start with this one. So M1, 2 is going to be a 2 by 2 matrix. So we have here, we cross out this row, this column, we're left with 2, 3, negative 1, 1. So the determinant of M1, 2 is 2 minus a negative 3, which is 5. So we can erase this and put 5. Okay. Now let's find the determinant of M2, 2. Cross out this row and this column. We're left with 1, 3, negative 1, 1. So the determinant of M2, 2 is 1 minus a negative 3, which looks like 4. Erase this. Put a 4 here. And then the last one, cross out this row and this column. It looks like this is M3, 2. So we have 1, 3, 2, 3. And we're left with 3 minus 6, which is a negative 3. Okay. Now let's figure out what this sum is. So this is 2 times negative 1 times 5. This becomes 3 here. This negative 1 is just a positive 1 because 2 plus 2 is 4, so it's an even power. So plus 4, and then this is minus 1 times 3 times a negative 3. So it looks like negative 10 plus 4, and then plus 9, which is negative 10 plus 13, which is 3. We got the same answer that we got before. Now you can go along any row or any column and you should get the same determinant. So along this row or this row or this column or this column, you'll always get the same answer. Alright, I want to do one more, but I want to look at a bigger example. And actually what we're going to do, we're going to take advantage of something that we see in this matrix that we didn't see before, which is we have some zeros. When you decide that you want to go along a row or a column, always go along the row or the column that has the most zeros. So to find the determinant of this matrix is going to be more work than the last matrix. Particularly if we didn't have any zeros, it would be a lot of work. But it's going to be less work since we have some zeros than something without any zeros. So what I'm saying is you need to either go along this row or this column. Okay, I think I'm going to go along this row. If you go along this column, you'll get the same thing. And I'm going to show you why you want to choose this row with all the zeros. So I'm going along this one here. Now think about what's going to happen when we get the minor matrices. When you get a minor matrix, you're going to get a 3 by 3 matrix. And then to find the determinant of that 3 by 3 matrix, you're going to have to do exactly what we did here. But you'll have to do it, looks like you're going to have to do it 4 times. However, because you have these zeros, remember these numbers go in front of those minor matrices. We multiply the determinant of the minor with this number, so then we don't actually have to find the actual determinant of the minors associated to this entry because it's going to equal 0 when we multiply it by 0. Okay, so let's get started. The determinant of B is equal to, we start with this 2 times negative 1. Now this is the entry A, 1, 2, 3, 4, 1. So it's 4 plus 1 times the determinant of M, 4, 1. Add to it. This is A, 4, 2. So this is going to be negative 1 times negative 1 to the 4 plus 2, determinant of M42, plus zero times negative 1, this is A43, to the 4 plus 3, determinant of M43, plus 0. This is A45, 4. 0 times negative 1 to the 4 plus 4, determinant of M44. Okay, so you can see that I didn't even really have to write all of this stuff out because 0 times anything is going to be 0. So this is just going to be 0, and so is this one. So I really just need to figure out these two pieces. So what is the determinant of M41 and M42? Let's start with M41. So M41 so here is A41, cross out this row, that column and cross out this row. See, this is your matrix. Sorry about that. Let me scroll back down. Okay, so we need to find the determinant of this matrix. And now we have to apply that formula again. Now, as I recommended, when you have a matrix, you always want to go down the row or the column that has a 0. So let's go along this row. So then the determinant of M41 is 1 times -1 to the, now this is the A2, 1, so 2 plus 1. Now this A doesn't correspond to the original matrix. This is a new matrix, so that's why I put this little prime here. Times the determinant of the minor matrix, and this is gonna, let's call it a different minor. This is minor M21 plus 0, and we don't need to worry about what we need to multiply it by, plus, then we need to take this one, which is 1 times, this is the A prime 2, 3 spot. So we need the determinant, well, -1 times, -1 raised to the 2 plus 3 times the determinant of M prime 2, 3. Okay, so let's figure out these determinants. Let's start with this one. M21 corresponds to this matrix 1, -2, 2, 2. So M21 prime is 1, -2, 2, 2. The determinant is 2 minus a -4, and that is 6. So we can erase this and put 6. Now let's find the determinant of this matrix. So that corresponds to this entry. Cross these out. We have -1, 1, 1, 2. That is this new matrix, which is M23 prime. So our determinant is -2 minus 1, which is -3. So I'm going to erase this and put -3. And let's add these up. So what do we get? This is going to be -6. Then this is a -1 times a -3. So we get -6 plus 3, which is -3. So that is this determinant. So we've excuse me, so we figured out this piece, and we can put -3 here. Now we need to figure out this piece. So we have one more determinant we need to find. So let's repeat. It would be a good idea for you to try to find this and make sure you get the same thing I get. Okay. All right, so we need to find M42. I'm going to erase all of these entries. Let's circle the entry 42. So 4, 2 is right here. We cross out this column and this row. So our matrix is 1, 1, negative 2, 3, 0, 1, and 0, 2, 2. What is this determinant? Okay, pick your favorite row and your favorite column. This time I'm going to go down this column. So we're going to get 1 times negative 1 to the 1 plus 1. And now I'm going to actually put the matrix here. 0, 1, 2, 2. Usually I put determinant of A1, 1, but these lines, when you put straight lines like this, you'll see this in the book. That means you want to take the determinant of this matrix. Okay, then I'm going to go with this 3, so plus 3 times negative 1 to the, now this is the 2, 1 entry, so 2 plus 1, and then the minor matrix is 1, negative 2, 2, 2. And I chose this column because it had a 0 in it, so I don't have to worry about this third minor matrix. So this is equal to 1. This is going to be 1 times the determinant of this matrix is 0 times 2 minus 2 times 1 plus 3 times a negative 1 times 2 minus a negative 4. So we get, this is 0, minus 2 plus negative 3. And this is 2 plus 4. So I have negative 2 minus 3 times 6, which is negative 2 minus 18. I got negative 20, assuming I didn't do anything wrong. So then the determinant of M42, we say negative, yeah, negative 20. And I'm going to put that right here. Okay, now I think we're ready to calculate the determinant of the big 4x4 matrix. So this is 2 negative 1 to the 5th times negative 3 plus negative 1 negative 1 to the 6th times a negative 20. So this is just negative 1, so we get negative 2 times negative 3 plus 20, because this is a positive 1, negative and negative, okay? So it looks like we are left with 26. And that's our final answer, assuming I didn't make any mistakes. If you find a mistake, please let me know. So now we have an idea of how to do determinants for bigger matrices. And you can see if you had a 5x5 matrix, then you would have to get minors that are 4x4 and then try to find the determinant of those. And to find the determinant, you'd have to get minors of those matrices that are 3x3 and then minors of those matrices that are 2x2. So it would take a lot of work. Something I wanted to mention is that there are some matrices that you can find the determinant of really quickly. So let's talk about a lower triangular matrix. Now recall that a lower triangular matrix, C, looks like this, where the only places that you can have something that's non-zero is on the diagonal or below the diagonal. And here I have an example of a 4x4 lower triangular matrix. Right? So it's lower triangular. What is this guy's determinant? This is actually something you can figure out really quickly. You don't have to do a whole lot of work, because let's remember what we did before. I said that if you have a big matrix and you have a bunch of zeros, you want to go along the row or the column that has the most zeros. So to find the determinant of such a matrix, go along this row. So this is going to be 1 times -1 to the 1 plus 1, because it's the 1, 1 entry. And then we cross out this row and this column, and then we're going to multiply by the determinant of another lower triangular matrix. Again, these straight lines means take the determinant. Well, if we wanted to take the determinant of this matrix, what we would do is we would go along this row, and you're going to do the same thing. So this is going to be equal to, now notice that because we were on the diagonal, this -1 is going to be raised to a positive power, because it's always going to be double, because if this is the 1, 1 entry, so 1 plus 1, so we get 1 times, so we have 3, because we're going to go here, cross these out, and you're going to take the determinant of 8, 0, 1, 1. Okay, and then you're also going to multiply by -1 to the, well, this was the 1, 1 entry here, 1 plus 1, but that's going to be 2. So you don't even have to worry about this negative. And then the determinant of this is just 8. So you get 1 times 3 times 8 times 1. So the thing is, if you have a lower triangular matrix, the determinant of it is just the product of the diagonal entries. And this is true for a lower and upper triangular matrix or a diagonal matrix. So the determinant of A is the product of the diagonal entries.